Hi everyone, I'm Violetta Fulchiati, Marketing Specialist for Zivan, part of the ZAPI Group companies. Welcome to this session. Please remember that this presentation is also being recorded and will be available to watch on demand following this session. If you have any questions during the session, please add them to the Q&A. You can find that tab on the right of your screen. Note that your questions will be sent privately. With that, I would like to introduce our speakers. I'd like to welcome David Began and Antoine Ampé from BlueBotics, who will be speaking today about vehicle automations, mistakes to avoid. Welcome, David and Antoine. Please take it away.
Thanks. Thank you very much. So as we wait for everyone to join, we will quickly introduce ourselves. So I'm David Beguin, Senior Sales Manager at BlueBotics, with over 5 years of experience in autonomous navigation sector.
And I am Antoine Ampé, so a lead systems engineer at BlueBotics, and I've been working for a bit more than 6 years at BlueBotics now.
So at BlueBotics, we help companies meet the challenge of vehicle automation. And to do so, we provide the navigation technology and expert support they need to bring their AGV, automated forklift, or mobile robot successfully to market. To give you an idea, our end navigation technology is in operation in over 5,000 AGVs around the world. As we've helped AGV producer to automate vehicles for over 10 years, we've asked our expert team to identify the most common mistakes vehicle makers make when they do develop an AGV. So here are the 5 mistakes and how you can avoid them. The first mistake is not knowing your vehicle application well enough. So every industry has its own specific need, and an AGV that is made for automotive sector, for example, will probably need to perform very different functions than a warehousing product or an hospital logistic robot. Another example is many AGV manufacturers start projects with the ambitious goal of sub-centimeter accuracy, but in many cases, like in warehousing, for example, an accuracy of about 1 centimeter or half an inch is usually more than enough. In the other end, a generic vehicle that an AGV manufacturer try to design to suit as many applications as possible may at the end suit none of them, and it might even explode the development budget. So my suggestion are, if you need high precision, in any case you will need to choose higher end component, and for the last millimeters or so, use mechanical guide, for example.
And so another solution would be, it's really important to define what success looks like. So before you reach out to a possible automation partner like us, BlueBotics, or even if you begin your own AGV, so your own prototype, you really need to begin to define exactly what you want your vehicle to do. And then you will explore whether or not it actually needs to do this for the concrete application at the end customer. So once you have these specifications, you can draft a vehicle and you will run it past suppliers, but also potential customers, because at the end of the day, customers are really the one you want to make an AGV for, and suppliers are really used to, let's say, to partners like you. So it will really make sense. And then it will also allow you to see what features that are really needed in your AGV, but also maybe you will need to remove some of them because they're not really needed for the end application. You can do this as early as possible and then be prepared to adapt your plans. At BlueBotics, we sometimes see companies skip this step and they move forward with too much complexity. and the result is almost always an unsuccessful product. Now we can move on to the second mistake that we identified, which is not hiring the right number of people. So missing expertise. When you're starting an AGV development project without the right in-house expertise, it can easily lead to stress or to unplanned expenses. So you will need a roboticist on your team, for example, and it will need to be an expert in mechatronics. So mechatronics will be skills in mechanical, electronics, and computer engineering. It is really meant to ensure that they know how your vehicle works from end to end. So not having the right level of knowledge in-house can lead to costly mistakes. Installing a wrong component that is meant maybe for manual vehicle, if you try to adapt it to your AGV, it won't work. It can also lead to long delays. Your mechanical engineer will try to learn computer programming. I mean, it's not his job, it's not his formation, so it makes no sense. And it's so that is really meant during the development phase, but it's also really important for the future, because when your AGV will be running in an installation, you might face a few support calls. And so if your team doesn't really know how the vehicle works, they won't be able to fix it or even to install it. So it really needs to have the right number of people. And so there is also the bus factor to take into account. It is the risk for your business if one of your employees disappear from a project because they were hit by a bus, or most likely maybe they leave the company or retire. But the result is the same, minus maybe the visit to the hospital. But if you are only a single point of knowledge for your AGV project, you risk this project grinding to a halt if the team member leaves.
Yeah, and of course, if if you take the potential cost of losing this brain to your business, maybe we think it's better to build a slightly larger team right now, and to avoid this. We think it is worth it to consider that. Another very important point is the need for technical post-sale staff. So who will be the guy that will go to install those AGVs or AMRs to your customers? Yeah, we've seen a lot of companies considering this too late. Yeah, on this topic, yeah, on this topic, still we didn't see is not only valuable for components and system. We think it's also important for employees. The way we see it is try to overlap some skills and some competencies. Of course, we can imagine it's quite complicated to hire two electrical engineers to do the same thing to the CEO, but at the end, to have guys that can overlap and even do something that is a little bit out of their 100% focus, that and to play also on a cool robot project might be a good thing. And as Antoine was mentioning, to avoid the bus problem, make sure that your team creates great documentation. Because of course, when you have new staff or you need to replace guys, it is much better for the onboarding. What can be considered as well is to have a series of screenshots or video record can be enough. Maybe not writing a book of documentation, but at least having something seems to be key. The third mistake is focusing on the wrong cost. I will let Antoine talk about that.
Yeah, so I'm sure that you already know that, of course, AGV development is expensive, but what we have learned at BlueBotics from working with vehicle makers around the world is that cutting corners on hardware in the beginning often leads to increased costs in the long term. So, for example, in a typical AGV project, hardware selection and programming will represent almost all of the time spent and less than half the cost. So it makes sense to invest a lot here. It's really because, let's say, hardware selection at the end of the day, you will only look at the price of the components, but not really at the time spent, because it's less seen as a cost, but in the end, it's really the biggest factor. And also, don't forget that if you want to create an accurate vehicle, you need accurate measurements. And so it means that your hardware needs to be robust and of high quality. And so especially components that measure variables, so like the angle of a steering, the speed of a motor, the height of a lift, you will have the occasion to save $50 here and there to save costs, but in the end it can compromise the whole vehicle in its entirety. And this is also true for the rest of the project. These choices can cause problems when installing or maintaining the AGV. Going for the cheapest wheel that will break every 6 months is maybe not the best. During production, it makes sense. During runtime, it makes no sense anymore. So our solution is really choose top of the line. Let's say when you're designing and prototyping your vehicle, do not spend too much time looking for alternatives. Think long-term and go for the best possible components, by default at least. And then once you have your IGV ready, you have the components, let's say you have your end application working, then you can begin to evaluate the difference in price. So between the top shelf components and the standard ones, or even subpar in some cases, and it will give you a good alternative, let's say an idea of alternatives to test. And you will see you may find some space for major savings, or the difference may be a lot less than you think. Also considering that it might mean that you will juggle between several versions for the same HGV in the end. So it can be a big problem in terms of documentation and know-how. Now we're moving on to the fourth mistake, which is automating the wrong vehicle.
Okay, then, Antoine. As BlueBotics and navigation technology is flexible, accurate, and robust, so with a technology like that, you can automate whatever vehicle you like, such as an existing forklift, right?
Well, in theory, yes, but in practice, it is always a bit different.
Okay, this means I can use my 25-year-old forklift?
Well, I will not really recommend it, because your vehicle components will probably not be reliable for an additional 10 years. So it will only bring more problems to a new project.
Okay, gotcha. But may I use a brand new vehicle that is manual and automated?
Yes, let's say as long as you can make the necessary adjustments to automate it, you will need to consider a few different areas that we'll go over, such as controls, components, and safety integration. So to begin with controls, of course, you will need to ensure that your vehicle interfaces are ready for automation. For example, a steering wheel directly connected to a driving wheel will need some major adjustments in order to be automated. In a similar way, manual vehicles often rely on devices, let's say, not even equipped with sensors. And to automate them, you need these sensors. For example, the gas pedals on a forklift, some push buttons, some levers to control the height of the fork. So it will mean some major adjustments and additional hardware in the end. And so, of course, then you might think a universal solution could be to develop a 64 degrees of freedom humanoid robots. Well, actually, it's a really great solution. It will be able to take over almost any kind of vehicle quite quickly. Well, the only catch to that is you need to take into account the price of these developments, and I think it might be a bit overkill.
Yeah, makes sense. But at least can I reuse my components that already exist or are already inside my vehicle?
There again, it's more or less a case-by-case situation. As mentioned, manual vehicles often relying a lot on hydraulics. Hydraulics are not easily automated, so either it will be a lot of adjustments, or they might need to be switched up for electronics, so it's already a big adjustments. And it's also, if you need to add sensors, it can be as simple as needing a new encoder on a motor shaft, a potentiometer on a lift, something like that. Well, they actually need to physically fit inside the vehicle. It sounds like a small problem at the time, but really I've seen it a lot of time. You need to cut out the vehicle, and it's quite a problem. And then once you have So you have selected all your components, you have seen that they are compatible with the automation you want to perform. Then all these components, they will need to discuss together. And they will need to discuss together in a common protocol, in a common field bus maybe. And so you need to make sure that all of them support the same one. And so all of this needs to be really carefully analyzed before moving on.
Okay, and what about the safety? My vehicle has already some certification. May I keep it?
Well, unfortunately, not really, because an automatic vehicle and a manual one are quite different, even if you automate it. For example, to have an autonomous vehicle, you will need to make sure that no one is currently driving it. It means that detecting that no one is touching the steering wheel, no one is sitting in the chair. All this kind of stuff will need to be adjusted for this manual vehicle. And basically, these problems would not exist if you were prototyping AGV from scratch. It can be also problems like adjusting the safety scanners, for example, that you need to mount to your AGV. To ensure a sufficient field of view, you might need to add cutouts to the vehicle chassis. And so all of these considerations, they can lead to additional hardware, additional costs, and additional time spent in the end, and so money spent. So in conclusion, the solution is to discuss again and again what are the customer needs and then craft an adapted solution. It's really, in some cases, maybe automating this manual vehicle will make sense. In some other cases, it will be prototyping a complete new AGV. Again, a case-by-case situation.
Okay, thanks. So now let's go to the last mistake we identified, which is underestimating sales and marketing. So as we know, AGV development is a significant financial and time investment. So you will get the best return on investment by ensuring that as many people as possible hear and see about your creation. We think that making marketing a priority is obviously key. So even for a small AGV manufacturer, it is really a good idea to think beyond the R&D and to think about what's going to happen after we've built and we've designed our AGV. We also recommend to invite the sales staff to the development right in the beginning, because they can provide very valuable feedbacks from customers. During all the process, it's also important to let your marketing manager to come and to take pictures and videos, because at the end it will be very important to do the promotion for some marketing posts. And a good practice that I've personally applied is to offer to beta customers a discount in exchange of permission to advertise and talk about their installation using your AGV. Then what if you don't have marketing staff? So of course, it's not the case of all the companies to have the capability to have a marketing staff. So what can you do? We recommend to find an agency or a freelancer. Now there is a lot that you can do if you outsource this. So this is a good way to investigate. We also think that collaboration is really key. So we are lucky, we are in a B2B business. So most of the time you have suppliers, customers, and thanks to that, we can do some great and valuable collaboration. So what you can do, you can ask your supplier, for example, to highlight your vehicle on their website and to talk about it to their sales team. So at the end, your vehicle will contain some of their components. So then it's a win-win situation. Then after the installation, you can also ask to your customer to talk about how using your AGV has made their business more efficient. Such a success story, it's not only advertising about you, but it's also, it will speak about them, how they embrace and they are facing the future of the technology. And there is also a lot of digital marketing that are really easy to access and really cost effective. The main one we would recommend are obviously Google Ads to get found in Google search, LinkedIn post and ads to target that can be targeted by industry, region, or job title. And you can also engage again your supplier to do a joint press release, and maybe you can talk about why you choose them as a partner. That will be great for them, but in the other end, it will also help you to advertise your own project. We think that the bottom line is in your AGV project to be successful, because at the end, the goal is to sell this AGV, otherwise you won't do it. So it's to consider sales and marketing as a line item from the beginning, and it will give you the best chance of success. And then a topic that I know pretty well is about sales. Ensure that your sales team don't have to sell something that is brand new, that is a prototype. So make sure it is a product that they are confident in selling. It's very important. And also make sure they have the skills to sell this product, because selling a manual forklift, for example, it's one thing, but to sell an AGV, it's something very different. And investing in training, we are really convinced that is key. We've seen some of our customers that were facing this situation, so they were coming from forklift. They were selling forklift, but and at the end, when they started to sell AGV, the sales team were not well trained, and they had some problem on that. We think it's also very important to have the incentive to the sales guy that is really linked to the strategy, because obviously it's easier to sell a manual vehicle than to make the effort to sell an AGV instead. The sales guy should feel the need of that and the value of that. And of course, again, always try to include the sales guy from the beginning, because then they will have the feeling of being part of this project, and it will be easier for them to sell. Finally, developing an automated vehicle is not easy, but we really believe that it is worth it. So as we said, on BlueBotics, we've helped AGV manufacturer to develop over 180 vehicles during the past 10 years. So we have a dedicated team that are now really expert. So if you want to take this journey, be sure to reach out to us via BlueBotics.com or to drop your email address or contact us later on. This is the end of this session, and to summarize, the 5 common mistakes we've addressed today. The first one is know your application. It's really key. Not every AGV can suit any application. Build a dream team, and make sure to not encounter the bus factor. Focus on the right cost. Antoine explained it in a very good way. It's really key. Automate the right vehicle, and don't forget sales and marketing. So we are happy to answer any question you have, either now or to schedule a call.
Hi everyone, thank you so much to David and Antoine for the great insightful session. So in the meantime, we got a few questions from the audience. So the first one is, in your opinion, out of these 5 mistakes that you mentioned, which one is the worst to make?
Really good question. So my guess, I mean, I think the third one, so focusing on the right cost, because from my experience, kind of all of the issues, not hiring the correct staff, or let's say, kind of forgetting a bit about sales and marketing. Let's say, once you identify the issue, you find a solution, and then most probably the problem will be solved, and then you can move forward. Focusing on the right cost can really, I've seen it personally. It's you choose a wrong encoder, you choose one wrong component at the beginning, you move forward, and then when installing the AGV, you realize this was the wrong component. Then you need to move backwards to go back to this decision, correct it, and then move forward. So I think it would be the let's say the most costly mistakes at least.
Okay, Antoine. So the next one, have you ever used an automotive servo to manage the steering of an automated vehicle? And is in general the steer-by-wire solution always preferable?
Yes, I've seen both. Then it's kind of coming back to the issue of adapting the components, because yes, you can adapt kind of having as you mentioned a servo EPS on top of the steering wheel, but then will it be mounted like in the vehicle cabin itself? Will it be mounted to the chassis? How will it be done? What kind of components will you be looking for? I guess you won't have access to the CAD drawings of the manual forklift manufacturers. So it's kind of all of these small issues that seems like, oh, I will do it quite quickly, but in the end, well, as you mentioned, steer by wire, then it's just, okay, it's compatible with a field bus, I don't know, can open. Okay, compatible. Then it's sending data, and then you can adapt more easily. So I would say so steer by wire is maybe not always preferable, but I think it will always be the easiest one to implement, in my opinion.
Thank you so much. So another question. How long does it take to automate an AGV starting from scratch?
I take it. Good question. It really depends. Most of the time, it can go typically from 4 months to, I mean, if you put the right effort, of course, 4 months to 1.5 years. It will depend on the complexity, on the experience, of course, on the budget you have, the team you've built, and so yeah, all those factors may impact a lot the time to have this AGV ready. But we've seen great stuff. Like I said 4 months, but we've seen customers that already had kind of a design, but really that was not really made for AGV. It was, for example, automating a manual forklift. It can take really few weeks. I don't want to say few weeks, but about 2 months. So, but because the guys were ready, it was pre-COVID, so of course before any supply issues and so on, and the guys were well organized. But I think usually we answer to this question to minimum 6 months to 1.5 years.
Okay, great. Thank you, David. So I think we addressed all the questions. So thank you so much, guys, for this session. And thanks for the audience for being there. You're welcome to join the other sessions from the lobby. And thanks, everyone, and have a nice evening. Bye-bye.
Thank you very
Thank
much.
you.
Bye, everyone.
Bye.
Bye.